Hi, this is Javin Kharod, a chemical engineer by profession, going to start our today's topic, plate heat exchangers. Now, what is that? A plate heat exchanger is a type of heat exchanger that uses metal plate to transfer heat between two fluids. This is major advantage over conventional heat exchanger in that fluid they are exposed to a much larger surface area because fluid are spread out over the plate. This facilitates the transfer of heat and greatly increases speed of temperature change. Plate heat exchanger are now common and very small brass version are used in hot water section million of combination boiler. The high heat transfer efficiency, such a small physical size, has increases domestic hot water flow rate combination boiler. The smaller plate heat exchanger has made a great impact domestic heating and hot water. Larger commercial version use gasket between the plate where smaller version tend to burst. The concept behind heat exchanger use pipe and other contaminant vessel heat or cool one fluid by transferring heat between it and other fluid. In most cases, the exchanger consists of coiled pipe contain one fluid that passes through chamber contain another fluid. The wall of pipe they are usually made of metal or another substance with high thermal conductivity to facilitate the interchange, whereas outer casing of the larger chamber is made of plastic or coated with thermal insulation so discourage heat from escaping from the exchanger. Now design of plate and frame heat exchanger. A plate heat exchanger is a specialized design well suited to transferring heat between medium and low pressure fluid, welded, semi-welded, brass heat exchanger are used to heat exchange between high pressure fluid or where more compact product is required in place pipe passing through a chamber where instead two alternating chambers, usually thin in depth, separated their larger surface by corrugated metal plate. The plate used in a plate frame heat exchanger are obtained one pieces pressing of metal plate. Stainless steel commonly use metal for plate because of its ability withstand high temperature, its strength and its corrosion resistance. The plates are often spaced by rubber sealing gasket which are cemented into a section around edge of plate. The plates are pressed into from through at right angle to direction flow liquid which run through channel in the heat exchanger. This through are arranged so that they are interlinked with the other plate which form channel with gap 1.3-1.5 mm between the plate. The plates are compressed together rigid frame from an arrangement parallel flow channel alternating hot and cold fluid. The plate produces extremely larger surface area which allow for fastest possible transfer, making each chamber thin absorb the majority of the volume of liquid contact the plate again aiding exchange through also create a maintain turbulent flow. The liquid maximize heat transfer in the exchanger. High degree turbulence can be obtained. Flow rate and high heat transfer coefficient can be achieved. As compare cell and tube heat exchanger, temperature approach, the smallest difference between temperature, cold and hot stream in a plate heat exchanger may be low as 1 degree centigrade, whereas cell and tube heat exchanger required approach 5 degree centigrade or more for the same amount heat exchange. The size of plate heat exchanger is smaller because of large heat transfer area afforded to the plate and larger area through which heat can be traveled. Increases reduction heat transfer area is simple plate heat exchanger through addition removal plate from the stack. Now, evaluating plate heat exchanger. All plate heat exchanger look similar on the outside. The differences lies on the inside. The detail of the plate design and sealing technology used. Hence, the evaluating plate heat exchanger very important. Not only explore detail the product being supplied, also analyze level research and development carried, manufacturing post commissioning services and spare part availability an important aspect take into account when evaluating heat exchanger are form of corrugation with the heat exchanger. There are two types of intermitting and co-regulation. In general, greater heat transfer enhancement produced from given increases pressure drop, and they are more commonly used intermittent corrugation. There are so many different ways. Modification increases heat transfer efficiency. It is extremely doubtful that one of them will be supported commercial simulator. In addition, some of priority and pro-priority data can never be released. Heat transfer enhancement manufacturer, however, it does not mean any of pre-measurement for emerging technology are not accomplished engineer. Context information on several different form changes heat exchange given below. The main objective, the cost benefit heat exchanger compare uses traditional heat exchanger must be always fulfilled by heat exchanger enhancement, fouling capacity, reliability, safety. There are other considerations they should be taken. First, periodic cleaning. Periodic cleaning, on-site cleaning, is the most efficient method to flush out all waste and dirt over the time. The decreases efficiency of heat exchanger. This approach requires both side plate heat exchanger to be drained, followed by isolation from the fluid in the system. From both sides, water should be flushed out until it completely clear. The flushing should be carried out opposite direction, regular operation for the best result. One of it's done, it is time to circular pump and a solution tank. Pass cleaning agent, ensuring agent is comparable. Plate heat exchanger, gasket and plate. Lastly, until discharge stream runs clear. System should flush with water again. Optimization plate heat exchanger to achieve improve process heat exchanger. Two important factors, namely amount of heat transfer, pressure drop, have considered such that amount of heat transfer need to increases pressure drop needed to decrease in plate heat exchanger due to presence corrugated plate. There are significant resistance to flow with high friction loss. Thus the design plate heat exchanger they should be considered both factors. For various range, Reynolds number, many correlation, angle for plate heat exchanger exists. The plate geometry is one of the most important factor. Heat transfer and pressure drop in plate heat exchanger. However, such a feature is not accurate prescribed in the corrugated plate heat exchanger because of the narrower path between the plate. This is large pressure capacity and the flow become turbulent along with path, therefore require more pumping power and other type of heat exchanger. Therefore, higher heat transfer and less pressure drop are targeted. The shape of plate heat exchanger very important industrial application. They are affected by pressure drop. Now flow distribution and heat transfer rate. Design calculation. Plate heat exchanger include flow distribution and pressure drop heat exchanger. The former issue flow distribution manifold, a layout configuration. Plate heat exchanger can usually simplify manifold system. Manifold header are dividing and combining fluid which can be categorized U-type, Z-type arrangement according to flow direction of header as shown manifold arrangement. Now, Basciani and Martin developed a precious theory that design in recent years unfilled all the main existing model, developed most completed theory and design tool. The total rate of heat transfer between the hot and cold fluid passing through a plate heat exchanger can be expressed as Q is equal to mu A delta Tm, where mu is the U is the overall heat transfer coefficient, A is total plate area, delta Tm is the log mean temperature difference, U is depend upon heat transfer coefficient in the hot and cold stream. Now, manifold arrangement flow distribution. The cleaning help to avoid fouling and scaling without heat exchanger, needing shutdown operation disturbed. It order to avoid heat exchanger performance to decrease the service life of the tube extension. The on-line cleaning can be used standard approach in conjunction with chemical treatment the recirculating bowl type system, brush and basket system. Some of the offline cleaning is another effective cleaning method that effectively increases performance of heat exchanger, decreases operating expenses. The method also known as PG use safe like bullet device that is inserted each tube and using high air pressure force down the tube. The chemical washing, hydroblasting, hydrolancing, they are other widely used methods. The offline cleaning, both the technique when used frequently will restore exchanger into optimum efficiency until the fouling, scaling begin, slip slowly, adversely affecting efficiency heat exchanger. The operation and maintenance costs necessary heat exchanger, but there are different ways to minimize the cost. Firstly, cost can minimize by reducing fouling formation heat exchanger that decreases the overall heat transfer coefficient. According analysis, estimated effect of fouling formation will be generated huge cost, operational losses more than $4 billion. The total fouling cost include capital cost, energy cost, maintenance cost, and cost of profit loss. Chemical fouling inhibitor is one of the fouling control method. For example, acrylic acid, hydrochloroacid, and acrylic acid sulfonic acid copolymer can be used inhibit fouling deposition of calcium phosphate. Next deposition fouling can be reduced by installing the heat exchanger vertically as the gravitational force pull any of particle away from the heat transfer surface in heat exchanger. Second, operation cost can be minimized when saturated steam used to compare superheated steam as a fluid. Superheated steam act insulator, poor heat conductor. It is not suitable heat application such as heat exchanger. Okay guys, this is up to we shown today our topic plate heat exchangers. Now next chapter we have covered plate fin heat exchangers. Still then goodbye, do take good care of yourself and wishes you a very happy Sunday.